Welcome back to the GCSE Maths Pro YouTube channel. Today's video is the final part of the functions series, which is where we'll be looking at solving equations with a combination of all the different types of functions we've seen so far. So make sure that you've definitely seen the first 3 videos in this series, otherwise this final one won't make a lot of sense. And as a reminder, this is a higher tier topic only, so if you are foundation tier, you don't need to watch any of these videos in this series. So often with the functions question on your exam, it's probably going to be split into multiple parts. The first few parts will be quite straightforward. It might just be a normal function or maybe composite function or an inverse function on its own, something really straightforward. But you might have a part at the end where they've created some form of equation. So we're going to see a few examples of what I mean by that in today's video. As you can see, to start off with, we're just going to look at the normal functions. So, given that f of x is equal to minus 8x and g of x is equal to 4 times x plus 6, solve f of x is equal to g of x. So this is what I mean by the type of equation. They might get 2 functions, or 2 inverse functions, 2 composite functions, or any combination of those and put them equal to each other, for example. And then you have to actually find x. Obviously solving in general is just finding out what is x, isn't it? So in this case, because they're just normal functions, f of x, well, that's minus 8x, isn't it? Is equal to g of x, which we can see here, is 4 times x plus 6. So you can see I've just had to create that equation, basically. I'm just interpreting what they've said, and I said, right, okay, I just need to create this equation. At this point, we can basically forget about the functions. We're just trying to solve this, aren't we? Like a normal linear equation. So what I might do is either you can expand the brackets, or if you want, you can just divide across by 4 because 8 is a multiple of 4, so I might just do that. So I'm going to divide both sides by 4, but if you want to expand the brackets, that's absolutely fine as well. So minus 8x divided by 4 is going to be minus 2x. And I'm left with the bracket there's going to open up, isn't it? Just x plus 6. Okay. As you can see though, we do have x's on both sides of the equation, so don't get thrown by this. This can happen in any context, it's not just to do with functions. If you've got x's on both sides of the equations, and we know it's a linear equation, isn't it? There's no x squared or anything, it's just x to the power of 1. We just need to get them both together on the same side. It's up to you which side you want to put them on. I'm going to choose the side where I've got x as a positive. What I mean by that is if I was to subtract x here to move it to the other side, I still have minus 3x. That's fine, but ideally I want positive, so I'm actually going to move the 2x across to the right hand side, and then I'll just move the 6 to the left. So I'll just kind of swap them. So currently I've got 0 there equals 3x plus 6, and then I'll just move the 6 across to the other side. So actually let me just do that in one swift step. So I've also subtracted the 6 and swapped that. Now I just need to divide by 3, don't I? So divide both sides by 3. This is just normal linear equations, and you end up with minus 6 divided by 3 is minus 2, and obviously that's just x, isn't it? So x equals minus 2. We've solved it. It's literally that. So we just need to interpret what type of functions do we have, put them, in this case, equal to each other, and then just solve normally as if it's a normal equation from there. So here is another example of just normal functions. They've been put equal to each other. So pause the video and try this one out yourself first. So we've got, given that f of x is equal to 18x plus 81, and g of x is equal to 3x squared, solve f of x is equal to g of x. So I'm going to start by just literally writing both of those functions equal to each other. 18x plus 81 is equal to 3x squared, isn't it? That's basically what this tells me. Now I just need to rearrange this, don't I, and solve it. However, you see the difference here is this is now a quadratic equation, isn't it? It's not a linear equation. And the way we solve quadratics is different to linear equations. We can't just isolate the x on one side and move everything to the other side, because we've got x squared. It's more complicated than that. Most of the time, for solving quadratics, we're going to try and factorize. And I want to factorize by having the x squared as positive. So I'm going to move the 18x and the 81 to the other side. So I'm having to subtract those, aren't I? So I'm going to get 0 here. 3x squared minus 18x minus 81. Now you can factorize this as you wish now if you want, but I always check if I've got a number in front of the x squared, I always check if I can simplify the equation any further. Can I divide all three terms by a common factor? Well, luckily, yes, all of these are multiples of 3, aren't they? I'm just going to divide everything by 3 because that's going to make my life easier when I factorize. Just the same as if you were to divide or simplify a fraction by a common factor. It's still the same fraction, isn't it? We've just simplified it. Same here. Still the same equation. I've just simplified it. So now when I actually want to factorize 2 brackets, obviously x and x, don't need to worry about anything else. So we're timesing to make a negative, which means I need 1 plus 1 minus. Now factors of 27, then when I add them, I get minus 6. Obviously 1 being a plus, 1 being a minus. Well, that would work for 9 and 3, wouldn't it? 9 and 3, the difference is 6. Which one's plus, which one's minus? Well, I need negative 6, so I'm going to need negative 9 plus 3. That gives me minus 6, doesn't it? And to solve it, if you remember, obviously in the previous videos, we're just saying, let's say if one of the brackets equals 0. So let's say if x plus 3 is the one that equals 0. Do you see how then I get x equals minus 3? That's just now a linear equation, isn't it? Or, I don't know, maybe the other bracket equals 0. X minus 9 equals 0, so therefore x would be 9. Quadratic equations will always have 2 solutions, okay? So we've got 2 solutions in this case. Really, the functions part of the question is basically just understanding this line. Anything beyond that is just actually just algebra, isn't it? Solving equations. It's not really related to functions. Okay, so now we're going a little bit trickier because we're starting to look at our composite functions and how we can create an equation with that. So given that f of x is equal to minus 2x squared and g of x is equal to x minus 4, solve, now we've got f of g of x is equal to g of f of x. So you can see this is now a bit more complicated. We need to work out the expression for f of g of x and then put it equal to the expression for g of f of x. So let's break it down. Let's just do what is f of g of x first. This is why, obviously, if you haven't seen the first 3 videos in the series, definitely go check those out first, because we're not going to go into the actual composite bit in too much detail. It's more so the equation. So composite functions, we substitute in backwards, don't we? So the g function as a whole is going to go into the f function. So when I've got minus 2, and then where the x is, I'm going to replace that with x minus 4, obviously then squared. And then if I find the g of f of x, again, when you're doing it backwards, that's now f into g, isn't it? So putting f into g, I've got obviously x minus 4. So where the x is, I'm going to put the 2x squared. That's the whole of f. And then minus 4. Okay, now I can actually just put those into an equation, can't I? I know that these are equal to each other. So I've got minus 2 times x minus 4 squared is equal to minus 2x squared minus 4. Okay, that's all the functions done. Now I'm just dealing with equations, aren't I? So let's see how we can rearrange this. Okay, I might actually divide by minus 2 across first. I think I might do that. There's multiple ways that you can do this, but that's just a question of what you prefer, isn't it? So divide by minus 2 across, then minus 2x squared divided by minus 2 is just positive x squared, so that's a bit easier. And then divide minus 4 by minus 2, that's plus 4. Okay. Now I'm going to need to expand out this side, so that's technically double brackets, isn't it? So if I quickly expand it, I've got x squared minus 4x minus another 4x, so that's minus 8x, plus 16 equals x squared plus 4 there. Now this one looks like it's going to be a quadratic, but sometimes this can be misleading because let's say obviously with quadratics we want to get everything on the same side. So I'd be like, oh okay, I've got x squared on both sides, I need to get them together. But the way I would do that is I have to subtract one of the x squareds, don't I? And actually, do you see how that ends up cancelling out both x squareds? Because if I subtract this x squared and move it to the left, well, I'm subtracting x squared from this side, and I'm still subtracting x squared from this side, aren't I? And if I did it the other way around, it's either way I'm still cancelling out both of the x squareds. So sometimes they can do that, not just in functions, but in other questions. where it looks like it's going to be a quadratic, but actually the actual x squared parts cancel each other out. So now I've just got a linear equation, haven't I? Do you see how I've got minus 8x plus 16 equals 4? Okay, so now I know that I need to isolate the x, get it on its own, but I do want a positive x. So I'm actually going to move the 8x to the other side. I'm going to have to add it, aren't I? So I've got 16 equals 8x plus 4, and then I just have to minus the 4, don't I? So 12 equals 8x. Finally, divide by 8. Now, that's not a whole number. 12 divided by 8 as a fraction would simplify to 3 over 2, wouldn't it? Or 1.5 if you like. So x is equal to 3 over 2 or 1.5. Okay, so I know it's a lot to take in, but deal with it almost in steps. We've got step 1, which is the first composite function. Step 2 is the second one. And step 3 is then actually using the equation to solve it. Okay, so try this one out. This is another one with composite functions, although be aware, do you see the last bit is not g of f of x, it's g of x, okay? So, given that f of x is equal to x plus 1, g of x is equal to 4x minus 11, we need to solve f of g of x is equal to g of x. So as I said, let's just break it down. Let's do f of g of x first. So f of g of x, that means we're always substituting backwards, aren't we? So g into f. The whole of the g function is going to replace the x in the f function. So the whole of 4x minus 11 is going to replace this x. So we're going to get 4x minus 11, and we still then have the plus 1, don't we? Now, I'm just going to simplify that now, just because it's quite easy to, isn't it? So 4x minus 11 plus 1 is minus 10, isn't it? Okay, that's nice and simplified. Now let's do the g of g of x. So this one doesn't really matter so much which way around, is it? Because we're substituting the same function into itself. So we're going to substitute 4x minus 11 into where it says x. So 4x minus 11, bracket, and then minus 11 again. Okay, so we've substituted g into itself. And again, I might expand this and simplify it just to have it look a little bit neater. So that would be 16x minus 44 minus another 11, which is 16x minus 55, isn't it? And step 3, we're going to put it into the equation. You can obviously put it into the equation immediately if you want. I'm just breaking it down into smaller bite-sized pieces, that's all. So I know that both of these things equal each other. So I know that 4x minus 10, I can write it as equal to 16x minus 55. Now this one's quite nice because it's literally just a linear equation, isn't it? And again, if you've got x's on both sides, just move one of the x terms to the other side to combine them. And I always want to have a positive x if I can. So I'm actually going to move the 4x because I obviously need to subtract it. I would still end up with an overall positive number of x's. So subtract 4x, we still have minus 10. Don't forget there's a minus there, it's not just 10. 16x minus 4x, obviously 12x, that's still positive, which is great. And we still have minus 55. Now we're just going to add 55. So minus 10 plus 55 is 45, isn't it? Equals 12x, and then just divide by 12. 45 over 12, not going to be a whole number. But I would probably just simplify that fraction, which I know that 3 is a common factor, isn't it? So 15 over 4. Now I think that comes out as 3.75, but I'm just going to leave it as a fraction. So there is your solution. X is equal to 15 over 4. Okay, we have 2 more examples. We're now moving into solving equations with the inverse function. So given that f of x is equal to x plus 12 over 5, and g of x is equal to x over 2, solve the inverse of f is equal to the inverse of g. Well, we might as well break it down into those steps again. Let's just work out what is the inverse function of f. So if you remember, we're basically inverting it, aren't we? Now, this one I am going to just jump through a bit faster, just because I know how it's going to end up. So I know we're going to have to times by 5, so we get 5x, and we're going to then have to subtract 12. Obviously, I'd recommend you write it all out in the steps that we did in the original video, but this one I can kind of just see what's going to happen, and the same with the second one. So the inverse of g of x. I know that I'd end up having to just times by 2, isn't it, literally, so I'd end up with 2x. Okay, step 3, we want to put it into the equation. So we can see here that the inverse function of f of x is equal to the inverse function of g of x. So I can just make these two equal. 5x minus 12 equals 2x. Okay, really easy now, that's just a linear equation, isn't it? So I'm going to get all of my x's together. I'm going to move the 2x because if I subtract that, I still will have a positive number of x's, won't I? So I'll have 5x minus 2x is 3x, minus 12 is 0, and then I just need to move the 12 across, and I need to add 12 and divide by 3, which gives me x is equal to 4. Simple as that, okay? That's literally it. Okay, let's look at our last one then. We've got a slightly more complicated example here in terms of the functions, but obviously we're still going to be working in the same way. Let's break it down into steps, but can you see this time we've got a combination of the inverse function and a composite function. So really just make sure you read the question properly. So given that f of x is equal to 4x plus 3 over 6, and g of x is equal to 3 over 2x, we need to solve the inverse function of f of x is equal to g of f of x. Okay, quite a mouthful, but basically let's just break it down again. So let's find the inverse function first. So the inverse function of f of x, this one I'm just going to quickly go through and go, I know I'm going to have to times by 6, then I would minus 3, and then I'd have to divide by 4. Literally the opposite, isn't it? It's the inverse. Step 2, we want to find the composite function, so remember it's backwards, isn't it? So the whole of the f function is going to be substituted into the g function, so that way round. G of f of x equals 3 over 2 times by x, but in that case the x is the whole of the f function, isn't it? Okay, so we've got quite a complicated fraction here. Now you can write this into the equation straight away if you want. I might just multiply these two. It's basically just timesing two fractions, isn't it? So remember, when we multiply two fractions, we just multiply the top, so we multiply the numerators, and then we multiply the denominators. So I've got 3, now you can write it in brackets, I might just expand it now. 3 times 4x is 12x, and then also 3 times 3 is 9, plus 9. And then at the bottom, 2 times 6 is 12. Okay, cool, so now let's put them into the equation they've given us. Well, they've just said again that they're equal to each other. So 6x minus 3 over 4 is my inverse function, which equals 12x plus 9 over 12, which was my composite function. And now we're leaving behind functions, we're looking at algebraic fractions, aren't we? This is just algebraic fractions. So if we're solving this, again, it is linear, isn't it? Because we don't have any x squareds, and we're not going to end up with x squareds because nothing is going to multiply the two x's together. So I want to get rid of the fraction format, because that's just annoying, isn't it? So I'm going to cross multiply, which what I mean by that is, if I multiply it by 4 on both sides, it would cancel out this denominator, wouldn't it? But I would then have to multiply this numerator by 4, and if I then multiply by 12, it would cancel out the denominator on this side, but obviously it would affect the other side. So when I say cross multiply, we just tend to do those two things in the same step. You can obviously do it in one step and then do the second denominator in the second step, but I'm just going to do it together. So let's say we put it in brackets just so you can see. So I've got 12 times 6x minus 3 equals 4 times 12x plus 9. Okay, so now at least we don't have any fractions. Let's expand everything. As 12 and 4, well, 4 is a factor of 12. If you wanted, you could just divide everything by 4, to be fair. I'm just going to keep it a little bit more straightforward for the majority of people and just expand. So 12 times 6x, we know is 72x. 12 times minus 3 is minus 36. 4 times 12x is 48x. And 4 times 9 is 36. Okay, again, we're just in the same situation, aren't we, in terms of just linear equations. Let's get the x's together. I'm going to move the 48x because that's the smaller one. Given that they're both positive, I would have to subtract one of them, wouldn't I, to move it. So 72x minus 48x is 24x. And we still have minus 36 equals now just 36. Now let's add 36 to the other side. Don't get mixed up and think, oh yeah, those are going to cancel out. Because actually, if you think about it, I'm adding 36, aren't I? 36 plus 36 is 72, so they don't actually cancel out. And the last thing to do is divide by 24, isn't it? So 72 divided by 24, I'm going to write it over here. X equals 3. So we've solved it. There you go. So this is what I mean by solving equations with functions. Okay, this is more likely to be maybe like the part B or the part C. Might even just be its whole question itself if it's a really long one with quadratics as well. But you do need to be really happy with just algebra in general as well, because obviously it's kind of like the first bit is functions, but then the majority of it is just rearranging, solving equations, working with quadratics, factorizing maybe, expanding brackets, algebraic fractions, just anything in terms of algebra could come up, couldn't it? So don't get thrown off by the algebra part. Make sure that all of these kind of basic topics in algebra you're happy with. So we've covered pretty much everything that you would need to know for the functions topic. Thanks for watching this video. Obviously go back and check out any of the previous videos if you feel like you need to recap anything. And I'll link below also the playlist for algebra if you want to go back and check out any of those types of basic topics as well.